In this video, we are going to start our chapter on quadrilaterals. So the first thing that we are going to do is talk about what a polygon is and using some theorems about their angles, getting ready to move on to quadrilaterals soon. So first thing, let's take a look at what polygons are. So polygons are defined as a closed plane figure, okay? So a closed plane means a two-dimensional, okay? So plane means two-dimensional. So you could cut it out of a piece of paper. Closed means it can't have any openings. So no openings anywhere. And then it's formed by three or more segments. Okay, so remember that segments are straight lines. Okay, so they have a starting point, they have a stopping point. And they're straight. These are called the sides of the polygon. Each of those segments intersects exactly two other segments at the endpoints. So they can only connect at the endpoint. So if we had this segment, okay, it's got its endpoints, then we've got another segment, okay, its endpoints, and maybe we have a third one, obviously that is called a triangle, but you'll notice that they only intersect at the endpoints. They don't extend past the segment, so it's not going to be like this where it extends past, and it's also not going to intersect through the other segment because that would create three intersections. So let's take a look at some shapes down here. So remember that they have to be segments. So nothing with a curve is considered a polygon. So none of these with curves are polygons. Automatically outlawed if it has a curve. This one doesn't close. Okay, so any others with curves. So this one has some curved corners. So these are all non-polygons. Okay, another thing, so two-dimensional, I don't see any three-dimensional shapes down here. And then I talked about this where it can't intersect, it only has to hit at the endpoints, and it has to be closed. So this one right here is open. It doesn't close at the vertices, so that would be a non-polygon. This one as well, it crosses over and it doesn't, those other sides don't close. So that is a non-polygon. So if we take a look at the rest of these, we've got straight lines, okay, intersecting on the edges. This one might be a little bit confusing because maybe you'd initially think it's not, but it has all straight sides, nothing overlapping, no tails, nothing extending, it's closed. Same with this one, okay, these ones are all good. This one's good, all straight sides. Okay, this one maybe looks curved, but it has straight sides. This one, not good, because it overlaps, okay? It intersects three times along this segment and this one. Can't happen. This one, good. This one, good. This one, good. So in your notes, I would just draw a couple of these examples. You don't need to draw all of them, but just draw a couple so you can remember. Another way that we identify polygons, okay, so now once you have a polygon, so we're in all of these polygons, so now we're not looking at the non-polygons. So convex and concave have to be a polygon, so you'll notice no curves down here or anything. And then convex is all of the interior angles are less than 180, okay? So remember 180 degrees is a straight line like this. So they will be less than that. There won't be an angle that ends up bigger than 180 in a convex polygon. That will happen in a concave, okay? Also in a convex, all of the vertices point out of the shape versus in a concave, it looks like one is caving inwards toward the shape, okay? So caving in would be something like this. Notice that you see that angle in here that's more than 180 degrees. Okay, all of these ones are pointing outward. There's nothing caving in in any of these. Okay, so these are all convex. Okay, these two are convex. This one caves inward. It has vertices pointing to the inside. And let me move it first. You can see that you've got this angle right here. This angle is much bigger than 180, okay? And again, it points inward. This one has a spot that points inward, 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 inward. Okay, this one, everything is pointing out. okay, pointing out. So convex versus concave. Then we can label the polygons by their number of sides, okay, and you've probably heard many of these before, but the number of sides, if it's 3, is considered a triangle. Octagon is 8. Heptagon is 7, and actually heptagon has 2 names. You might also hear it called a septagon. Quadrilateral, which is what most of this chapter is going to be about, is 4 sides. Nonagon is 9. Decagon is 10, kind of like a decathlon is 10 events. Dodecagon has 12 sides. Pentagon has 5. Hexagon has 6. Okay, and then an n-gon is just any other number of sides. So if we said 11 sides, you would call that an 11-gon. Okay, so if I had any other number here, there are names for it. I'm just not going to, you don't need to know them. So if there's anything that's not on this list on the test, so if I said it had 11 sides, you would call it an 11-gon. Or 17 sides, you would call it a 17-gon. That's going to tell you how many sides it has. One other way to classify polygons is based on whether they are irregular or regular. So regular means that it's equilateral and equiangular. So all the sides and all the angles are equal. Okay, irregular would mean that it doesn't have that. There are sides that aren't the same, or there are angles that aren't the same. It could be equilateral and not equiangular, okay, for it to be irregular. Both have to happen for regular. So this one, not regular, because you've got smaller angles in here, okay? The angles clearly don't match. You see right angles here, non-right angles here. Okay, again, same with this one. A regular polygon actually can't be concave. So if it's concave, it's automatically irregular. Okay, this one has all the angles marked and all the sides marked as congruent. This one is regular. Okay, irregular, different sized sides. Irregular, these sides are clearly longer than that one. A rectangle is equiangular. It's got all 90-degree angles, but it doesn't have equal sides. So this one is considered irregular. This one, regular. Now just going by looks, these ones are also regular. A square has all 4 sides the same, all 4 angles the same. This one, all the sides are the same and angles. They're not marked up like they should be, but they are. All right, then let's talk about diagonals, okay? So diagonals just connect non-consecutive vertices. So if I grabbed this vertex here and wanted to draw in some diagonals, let me change the color of this. So if I wanted to draw in some diagonals here, I could just grab a vertex and connect it to any vertex that's not next to that one, okay? Because if I went next to it, this would be a side. So here's a diagonal, here's a diagonal, here's a diagonal, okay, and then this would be a side. So this hexagon, this 6-sided figure, has 3 diagonals. So that's going to help us actually determine the interior sum. So we've talked heavily about how a triangle has an interior sum of 180 degrees. So we're going to use that to help us with the rest of this. So a triangle has 3 sides, okay? Number of triangles formed by drawing in diagonals. You can't draw in a diagonal of a triangle. Okay, there's no diagonals. So there's only one triangle created here. It is the shape. So the interior sum here is 180 degrees. And that's what we talked about way back in like chapter 4 or maybe even earlier. So a quadrilateral has 4 sides. So let's draw in the diagonal on a quadrilateral. How many diagonals can we draw from one vertex? Just one. And then notice that we get 2 triangles here. So this triangle's sum is 180 and this triangle's sum is 180. Okay, so we have 2 triangles at 180 degrees each. So a quadrilateral or a 4-sided figure actually has an interior sum of 360. Pentagon. How many sides does it have? 5. Draw in the diagonals from one vertex. Okay, and this would be a side. So you'll notice that you have 1, 2, 3 triangles drawn here, each one having a sum of 180. So there are 3 triangles at 180. So the interior sum of a pentagon is 540. Hexagon, okay, so if you drew these all in, it would have 4. Okay, I can draw them in for you. So if we draw in the diagonals, we end up with 4 triangles here, which means 4 180s, which is going to be 720 degrees for the interior sum here. Now you can imagine if I was going to put a dodecagon here with 12 sides, I don't want to have to draw this and do all of this. But can you see a connection between the number of sides and the number of diagonals? Okay, 6 to 4, 5 to 3, 4 to 2, 3 to 1. That's down 2 each time. Okay, so if it's 12, then this is going to be 10. Or if I didn't know the number of sides, if I wanted to write a formula and I just wanted to say there are n sides, that means that there are going to be n minus 2 triangles, and then we would multiply that number by 180 to get the interior sum. So this is going to be our interior sum formula. So let's take a look. Okay, here's all those formulas. So we're going to write them in here. So we've got formulas for the interior angles and formulas for the exterior angles. So interior angles are inside of your polygon, exterior angles are outside. So what we just saw on the last screen is that the interior sum for the interior angles, the addition, or if you add them all up, is going to be n minus 2 times 180. If you had a regular polygon, let's say all 4 of these or all of these were the same. Okay, so if they were all the same, you would take your interior sum, which is n minus 2 times 180, and you would divide it by the number of angles that there are. So whatever n happens to be. Exterior angles are a little bit different because exterior angles actually always total 360. Always. It doesn't matter if it's 4-sided, 5-sided, 40-sided, the exterior sum is always 360. So if you had a regular polygon split into equal angles, so remember regular means equiangular, so all of the angles are the same, so you would divide by the number of angles. So if this was a pentagon, you would do 360 divided by 5, octagon 360 divided by 8, and so on. So let's practice using these formulas. So let's take a look at how this would come into play. So this is the sum of the interior angles. Okay, use that to help you find this missing value. So remember that that formula is n minus 2 times 180. So you need to know how many sides this polygon has. So just count the sides. Okay, that's what n is. N is the number of sides. So 1, 2, 3, 4, 5, 6 sides. So we would plug 6 in here. So 6 minus 2 times 180. 4 times 180 is 720. So all of these angles in here total 720 degrees. So we would add all of those angles up. So all 6 angles up. And they would total 720. Okay, much like we did with a triangle, we had 3 angles that totaled 180. A hexagon is going to be 720. So x plus 120 plus 130 plus 90 plus 130 plus 130 equals 720. So combine your like terms. So we're going to add all of these numbers together here. So we have what? 1, 2, 3, 400, 420, 450, 60, 70, 80, 90, 510, no, 500, 510, 600. Let me make sure. So use a calculator. Yep, 600. Okay, so x plus 600 equals 720. So then you can subtract 600 from both sides, and you will get that that missing angle is equal to 120 degrees. Since these are all numbers, you could just do 720 and just subtract all of these off of there too. Okay, let's do another one like this, so just a little bit harder with expressions. So again, we've got angles in here. Okay, so we need to know what the interior sum is. So we need to do n minus 2 times 180. N is the number of sides, so count them. 1, 2, 3, 4, 5 sides. So we'll plug 5 in. 5 minus 2 times 180 is 540. So the total here is 540. So we're going to add up all of these expressions. Okay, so 5, I'm just going to start adding them. So 5x plus 2 plus 3x plus 5 plus 8x plus 8 plus 4x plus 15 plus 5x plus 10 equals 540. So now you'll go through and add your like terms. So you'll find all the x's and add those together. So 5, 8, 16, 20, 25. Then you'll add up all of your integers. Okay, so 2 plus 5 is 7, plus 8 is 15, plus 15 is 30, plus 10 is 40. And you have that equals 540. So we'll solve for x and subtract 40 from both sides. So you'll get 25x equals 500. Divide both sides by 25. And you'll get x equals 20. On this problem, we see that we have exterior angles, so they're on the outside of this shape. So remember that the exterior sum, no matter how many sides it has, is always 360. Okay, so all of these angles, y plus 40 plus 65 plus 60 plus 70, all 5 of those total 360. So you can just subtract these from 360, or you could add them all together. So you can do 40 plus 65 plus 60 plus 70 is 235. Subtract 235 from both sides, and you'll end up with y equals 125. So no matter how many angles there are, the exterior is always equal to 360. So this one as well. So we would, is all exterior angles again. So we will add these together. So we have y, and if you wanted, you could look in here and just look for your, you have a y here and a y here. So y plus 2y is 3y. Plus, then all the rest of these are just integers. So 61 plus 59 plus 50 plus 35 is 205. So all of those angles total the exterior sum of 360. So we need to get y by itself. So we'll subtract 205 from both sides and get 155. And then divide both sides by 3. And we will get y equals 51.6 repeating. So if we wanted to round that to the nearest tenth, we could say 51.7. All right, then last couple here. The sum of the interior angles of a convex polygon is 3600. How many sides does it have? So take a look at what this one is asking for. It's telling you that the sum of the interior angles is 3600. So remember that we have a formula that says the sum of the interior equals n minus 2 times 180. Write down the formula. Okay, because then you can plug your information in. So you actually know the sum here is 3600. And then you are trying to solve for n. So personally, what I would do, since this is times this whole thing, is I would divide both sides by 180 so that those cancel. So 3,600 divided by 180 is 20. So you end up with 20 equals just n minus 2. Then to solve for n, you would add 2. Okay, and you get n equals 22. Now for this next one, I would think about this and think about exterior angles here. And so if we have a polygon here, okay, and an exterior angle is on the outside here. So if we look at this exterior angle compared to the interior angle, they make a straight line. I know this is kind of a crappy drawing. Let me use one of these. So if we, and we don't know how many sides it has, but let's just pretend here we have part of it. Okay, and then we extend one of the sides. Your exterior angle here and this interior angle always total 180. They're a linear pair. So I don't like to think about the interior angle. I like to think about the exterior angle. So I'm going to write in this 144 here, but I'm actually going to also figure out this exterior angle. So if they're a linear pair, if they make 180, I'm going to do 180 minus 144, and that's going to give you 36. Whoops, not 360, 36 degrees for that exterior angle. The reason this is nice is because the exterior sum is 360, always. Doesn't matter how many sides it has. So it's always 360. So then to get one angle, we could just divide by the one angle we know, and that would tell us how many sides there are. So if we have 360 degrees and each angle is 36, we would do 360 divided by 36 to get 10 sides.